Hello, we're going to be going over the SBMTrailers model cool train. This is the spring progress update for the spring of 2025. So the following contents that we will be going over in this presentation will be introduction, team roles, project timeline and major milestones, prototype and design updates, progression roadblocks and solutions, hydraulic system overview, engineering based design calculations, and the conclusion. Introduction. The project aims to build the foundation for developing a hay trailer that is road legal and compatible with a 53-foot NHTSA approved semi-truck trailer. Primary objectives include creating a self-loading and unloading trailer to eliminate the need for seasonal labor, improve operational efficiency, and reduce workplace risks associated with manual hay handling. Initial focus on small square bales, 14-inch by 35-inch by 18-inch, weighing up to 60 pounds, with adaptability for rapid collection and unloading at ports. Design goals: prioritize simplicity, safety, durability, and ease of maintenance. Above is our following team members. This is the SBMTrailers team. John Scotto, which is myself, is in charge of being investor relations and an experienced farmer. I secure funding by leveraging my agricultural business connections, which is serving as a primary contact for potential sponsors and ensuring financial resources are available on time for the materials and prototyping. In this image, we have Cole Tinsley. He's the lead researcher. Cole Tinsley focused on researching the legal and ethical codes, ensuring the trailer adhered to regulatory codes and other relevant standards. His work ensured that the design was not only functional, but also legally compliant and sustainable. Taylor B., team manager. Taylor B. managed the project, coordinated tasks, set deadlines, and ensuring team members stayed on track using tools like Gantt charts to monitor progress. His leadership kept the project organized and moving forward. Ethan Myers, lead CAD designer. Ethan Myers led the technical aspects, developing CAD models, performing load-bearing calculations, and ensuring the design complied with industry standards. His role was crucial in translating the concept into functional, manufacturable trailer design.
Thank you, Scotto. So my name is Taylor B. I'm going to be going over our project timeline. So this real quick is a quick overview for our initial proposed timeline. We can see that we really wanted to have our materials in the early October stage and then kind of start building around November and then hopefully start having our prototype by around the early of the year, January, February. And we'll kind of see as we kind of go into later detail that unfortunately this timeline was a little bit ambitious and it just wasn't, we weren't able to keep to it. So we just had to readjust and kind of reset our timeline and expectations. So diving further into that, as we kind of saw, we initially wanted to have it built around January. Um, we actually are kind of stretching that into February. We have the materials already and we've got them already cut up. We're in the process of currently building it right now. So we're kind of halfway in the stage of actually finishing up the build right now. The testing is going to be starting up real soon, though, over winter break. And then we're going to be doing an assessment on the design, verifying that it meets the requirements that we set forth for it, and it does the actual functions that we wanted it to. Then we'll go back to the drawing board, kind of refine it, and do any improvements that we can in the last minute to just kind of touch up. Or if we have to do any adjustments, this will be a good opportunity for us to do that. And then finally, we're going to be bringing in to St. Martin's for a demonstration, hopefully in person. If not, then we'll be doing a video demonstration where we record a video of it and then we show everyone with a video of how this operated and that it was able to do what we wanted it to do. Going on next, we're going to have Ethan Myers.
All right, so the Mark V is really just the Mark IV with some beefing up in key systems and then the addition of a few new capabilities due to Scotto's tremendous funding finding abilities. So we're adding on a hydraulic cylinder and possibly another one to add some automation to the header coming up and down, and then add a little bit more hay handling capabilities, just increasing the capacity of the hay we can keep on the trailer at one time. We've switched because of those hydraulic cylinders from an electric motor to a hydraulic motor, which will be ran directly off the tractor as well as the hydraulic cylinders. We also moved the motor back to a different spot to make it a little bit easier on like the length of the lines and just simplification after doing some redesigns. And additionally, because of those redesigns, we've beefed up some of the parts, specifically the shafts that the sprockets will be on that moves everything that the hay bales travel along. This is just as the design has progressed. One of the things that happened was our sponsor gave us material that was thicker than anticipated, so that's a benefit because it's stronger, but it's also a little heavier. So we just had to increase the thickness of some other things to accommodate that. Um, and finally, those some of those additions were to deal with the weight added on. So next slide, please, Taylor. So along the manufacturing process of this, one of the things that the Mark V improved upon was the drawings and the complexity of the CAD model because we've gone through 5 editions of the trailer. It's kind of brought along a lot of like baggage from the previous models and the drawings and stuff. So to accommodate this, Taylor and I have gone through and simplified the model significantly. It loads faster on computers. And also we've encountered some issues with the supply chain. So some sprockets that were going to come from one supplier ended up not coming. The chain that we ended up using is sort of proprietary, which has led to some complications, and we're investigating using alternative sprockets. And the shafts also we're going to need a custom shaft adapter just because we couldn't find a way around it. We're going to have to weld 2 shaft collars together to make the motor go onto the main sprocket shaft. Next slide, please, Taylor. Okay, so we're gonna make this easy to remember. We have a hydraulic cylinder on there. We got a hydraulic motor on there. We have some control valves and levers, which are on the tractor. That tractor has a hydraulic pump that keeps the whole system pressurized. And then we needed to purchase all the hydraulic lines and fittings. And then additionally, we added return lines for everything to go back to the tractor's hydraulic reservoir. So about half of those were already on the tractor, and then we added fittings for the lines to go into whatever they're going into. So you got tractor, fitting, line, another fitting, and component. Next slide, please. So, and if that still is a little confusing, so we're gonna go a little bit further here. So the hydraulic pump on the tractor keeps the whole system pressurized at all times. And when there is a place for it to flow, open like an opening in one of the cylinders or the valves that go to the cylinders, fluid goes out to those and can either extend or retract the cylinder or turn the motor on, make it start spinning. And the motors and cylinders convert pressure into motion of some sort with a torque in some cases or a force in others. And then after that, the fluid just returns freely to the system, taking up just a little bit of that pressure with it. Next slide, please.
Okay. I'll be talking about the engineering-based design calculations that were done for the hydraulic piston sorting system. The sorting system is meant as a proof of concept for a larger system that would be involved in a more usable commercial-based trailer. The function of the system is just to move bales from the left side to the right side and make space for more bales to come in. Again, as a proof of concept to show that we can handle bales that way. The required calculations included friction force calculation, piston force, and rail strength. So I'm going to be going over those now. Taylor, next slide. Right. For the friction force, pretty simple friction force calculation. The mu, the coefficient of friction, I got from a study done in Canada. Kind of had to reach out there to get a value for that because alfalfa on steel isn't exactly an average friction coefficient to find. Gravitational force equaling your normal force there, and it came out to 18.2 pounds of force for the friction. Taylor, go ahead. Right. Piston force calculation was a little more complex. I didn't realize all the things that kind of went into that. You have to account for the space that the rod is taking up inside the piston. That's that volume on the right side and your ideal gas laws. And on the left side, your area, your effective area kind of describes how you're getting push from that pressure, and had to account for, again, the rod area and the area surrounding it. Ended up with slightly more pressure, again, because you have to account for as the rod is leaving the piston, you're getting more volume, which will decrease the pressure a little bit. I'm still not 100% sure on all of this, but I'll keep working on it. Taylor, go to the next one. Please, thank you very much. And rail strength. So we're assuming that there will be 3 bales lined up on these rails. The rails need to be able to support that, and these are the calculations that I did that were done for that. Simple kind of bending moment and bending stress calculation. Low carbon steel should be fine as long as it's greater than 30,000 psi rated. Had to take the cross section, so that's the assumed cross section in the bottom right for those rails. And yeah, it's again, we've all done that calculation before. Taylor, that's all I've got for these. So thank you very much.
Awesome. Thank you, Cole. So we're going to go ahead and round it up here. So in conclusion, our project is on track. We're near conclusion, and our final assembly is about to begin, and we're about to start testing. We overcame some major challenges, and through teamwork and sponsors, we were able to overcome those and achieve an actual deliverable project. Our next steps is to, like I said, kind of complete the testing, finalize the prototype, and prepare for our final demonstration. And then our demonstration at St. Martin's University will showcase this, and we will let you guys know when that's going to happen. Thank you guys for listening. Here's our sources. If you guys have any questions, let us know. Thank you. Have a good one.